There are various types of mangroves, most of which are trees up to medium height and shrubs that grow in salt-line coastal sediment habitats in tropical and subtropical areas such as Hong Kong. It can also provide a home for fishes, crabs, and shrimps. This is an essential source of food for the coastal community. According to a study from WWF, the areas which consist mangroves provide 25 times more resources than areas where mangroves are removed. As trees which habitat in the mangroves are specialized to live in such a harsh environment, they evolved a characteristic which makes mangrove wood durable and useful fuel. Mangroves have dense root system, which enables them to trap sediments away from the river and stabilize the soil from erosion. Mangrove forests consist of diverse salt-tolerant trees and other plant species ranging from small shrubs to tall trees tens of meters high. Like coral reefs, mangrove forests are extremely productive ecosystem that provides numerous goods and services both to the marine environment and people. Twice a day, the water around them changes from salty as the tide comes in to almost fresh as it goes out, and the flow of the river water pushes back the sea. This is due to the fact that salt enters the mangrove through its root tissues. It can't be controlled and there are loads of excess salts taken in by the mangroves. By applying a pump mechanism, excess salt is forced out of the plant. This prevents salt from entering the xylem of the plant. This process is called ultrafiltration. Another way is through a salt gland. This allows the plant to continuously excrete salt away from the tissues of the plant, and then remove by shredding parts of the plant such as leaves and bark. Conductivity is the measure of capability to pass an electric flow. This is directly related to the amount of ions in a solution. Therefore, the higher the salt concentration, the more conductive it is. As the water passes the mangroves, the salinity of the seawater decreases, and the areas closest to the shoreline should have lower conductivity as the salt has been absorbed by the mangroves. According to the results from Site A and Site B, the conductivity of the soil increases as the distance away from the shore increases. Data from Site B have an overall lower value compared to Site A. This could be caused by the trees in Site A being shorter in height, which limits the amount of bark that can be shredded. It also indicates the number of mangroves are higher even though Site B was covered by seawater for a longer period of time. The conductivity of the samples from both sites are lower than the conductivity of seawater, which is 56,000 microsiemens per centimeter. The importance of controlling salt level is to allow organisms to have a suitable habitat to survive. If the salt level is too high, the organisms can't survive. The consequences of removing or destroying mangroves include the destruction of a whole ecosystem which consists species of trees, insects, animals, and birds. Increase in salinity and pH level in coastal area, increasing chance of flooding due to loss of trees to absorb water, economical loss as fishermen lose their job as water becomes more contaminated and polluted, and high level nutrient level causes eutrophication and species originated in the area becomes extinct.